Today we're going to talk about debugging. And this is a topic that we try to save a little bit later, but I've just noticed that most people have problems with this. And this is one of the biggest things that is, I would say, not talked about very often in sort of introduction to programming tutorials or books, because this is very personal. This is a very hard thing to teach. And I don't know that I can teach how to debug. So what I'll try to do is sort of share how perhaps professional programmers debug, and also how some small tips here and there. But ultimately, this is one of those things where it's a little bit different. Everybody approaches debugging differently, and everybody's appetite for debugging is different. And I would say that this is probably the most important skill to develop as a programmer, your appetite or temperament for debugging. So I'll share with you some of the patterns I've seen with regards to people who are learning the program, and how some of the people who have struggled to learn a program have struggled with debugging, and people who tend to have better success with learning the program are able to develop debugging habits very early and very quickly. So the sooner you develop these habits or skills, the more smooth or the more tolerable your journey will be to reaching that professional level of proficiency. So debugging is never a positive thing. I don't know that anybody ever sort of jumps for joy when asked to debug a problem. But this is what we do as professional programmers all day, every day. So as you get better at the basics, then you'll be working on harder problems or more complex problems that incorporate more subsystems or peripheral external systems and more complicated data flows. So you'll always be, as a programmer, sort of working on the boundaries of what you're capable of working on, usually, right? And typically that's what programmers do, because if you work on things that you are very, very comfortable working on, typically you're going to want to try to automate it, or you'll try to work at a higher level of abstraction. For example, if you get really good at building web applications, then perhaps, and you're getting so good to the point where it's a little bit boring, then perhaps the next step or next level up for you is thinking about architecture, right? So as programmers, there's always this sort of progression in the difficulty of problems you face, or you can move higher up in the level of abstraction in which you work, which is also more complexity, right? Which requires a higher level of abstraction to think about these more complex problems. And so you'll always be in debugging mode. The simple things that you might find hard now, that months from now or years from now you'll be able to work through much quicker, and so you'll be stopped at more complicated problems. So as programmers, this is it. This is all we do, right? Yeah, you might think that, oh, if I'm getting stuck on, for example, iterating through a nested hash today, if I master that, programming is going to breeze. That's not true. Iterating through a hash will be a breeze. The next thing that you're going to work on is going to be still a little bit, sort of right at the cusp of what you know and trying to figure things out. So learning how to debug is really the core of learning to work like a programmer. And the experience that you face in a program, in a rigorous program like ours, is the same type of feeling you'll have as you work as a professional programmer. So it's important to sort of get used to that feeling. Now, if you don't have that feeling, if you're just sort of working on the same things that's not very challenging, that's possible too, but it's likely that you will want to work in a more challenging environment, because that's typically where the best jobs are. That's typically where the highest paying jobs are, right? So if you're in a position or a role where everything's comfortable and you're not being challenged, typically that probably means you're going to be tempted to someone's going to give you more money, right, or give you a better role, better position, and you'll be tempted to go there. And when you get there, you're now back into learning new things mode and debugging higher orders of complexity. So the first thing I want to talk about is temperament. This is really about being patient and being logical. And so one test that I usually ask a lot of people is, how do you react when something bad happens, right? How do you react? If your TV stops working in the middle of a movie, let's say you're watching Netflix and all of a sudden something happens, what do? Somebody with a sort of logical and patient temperament might start troubleshooting. Okay, let me see. Is it the internet? Is it Netflix? Right? Is it a system problem on their end, or is it an internet problem on our end? Did my roommate or my wife or husband or my kid start downloading a large movie and therefore impact our bandwidth? Right? So these are all the thoughts that are going ahead. And if you don't have that temperament, the first reaction might be just, kind of throw up your hands and get frustrated. And that's perfectly natural, but as somebody who wants to work with code and speak to machines, essentially, you have to start to develop that temperament if that's not your natural disposition. And I can't emphasize this enough. And by the way, this is one of those things, and this is why debugging, I think, is difficult to teach, because this is not something that I can mention and snap of a finger, you're going to say, yes, I will go do this now, right? This takes consistent and prolonged changes in habit and changes in almost a natural reaction to when you're faced with a problem. And that's hard. That's hard. The second sort of attribute that I want to talk about is coding with intention. So in previous sessions of this series, we saw people walk through code. And what I notice is a lot of people, when they encounter a bug, they enter hack and slash mode to see if it works, quote unquote, right? I know that I kind of want an array here, but I'm just going to start messing with it until I get an array. That's okay if you're first starting out. Eventually, you're going to have to transition to a more systematic coding with purpose, coding with intention. And if you do need to sort of test to see if something works the way you think it works, hop off into another session, another IRB, or another editor, another file to play around with it, and then come back. So that when you're coding, you're writing code that you know exactly how it works, so it fits into the larger logic of your program. Really, really important to sort of develop that idea of coding with intention as opposed to writing some code and crossing your fingers, or just hacking at it without giving it too much thought. And I think that comes hand in hand with just this attention to detail. I think I've mentioned this a couple times before already, but we've been teaching people for a long time, many, many years now, and we see some patterns. For example, lawyers do really well in our program, typically. And part of the reason I think lawyers do really well in our program is because that's their job role. Their job role is to pay fanatical attention to the details. You don't have to tell them to do that. So when you code, every character has to be meaningful, right? In one of our assessments, for example, I have some code here. We ask, what is the difference between n plus 1 and n plus equals 1? Half the answers I get to this is, there's really not much difference, right? There's a tremendous amount of difference. Don't let this one little extra character go. Study it, understand it. Why is it there? Right? This is what fanatical attention to details mean. Not just because, it seems to me that when I use this, it returns the same value, so they must be equivalent. Right? Investigate that. And part of being sort of fanatical attention to details is sort of having that scientific mindset, right? Knowing the edge cases of how things work. Playing around with the simple constructs. Everyone's so interested in trying to learn the new thing. I want to learn something new. I want to learn the next thing, the next thing, the next thing. There's a lot of depth in every little concept. Try to play around with it and understand the edges of it. Where does the mental model of how arrays work fall down, for example? There's a lot of surprising behaviors in, for example, just a Ruby array. And part of the reason why it's surprising is because Ruby itself is an abstraction. Ruby itself is an abstraction. It's written in C, right? So sometimes, even as a popular language as Ruby, it leaks. The abstraction leaks. And so when you play around the edges, you're actually discovering how the underlying mechanism works, right? So fanatical attention to detail is important. And only when you pay attention to details can you code with intention. When people enter hack and slash, it's partly due to lack of the patient temperament, but partly it's also because they never had the sort of knowledge of the details of how things work. And so if you don't know how the details work, you can't really code with intention. This is why I said earlier, if you don't know exactly how something works, peel off into another editor or IRB and understand that little piece of code. All right, so those three things I think are personal attributes. I'll just mention them because these are the common attributes that I see in successful students that are able to finish our program, that do really well, that end up getting the competitive job offers. But it's unfortunately very difficult to say this and teach it, right? So that's the only thing I can really do is present the patterns and offer suggestions on how to change your mindset if you're not naturally like this, and to challenge you to pay even more attention to details than you already are perhaps. Now, as far as debugging goes, I would say the number one thing that people don't do, that when they sort of get in trouble, is when there's an error in the code. I'll show some examples in a little bit. I just want to talk about this real quick, and then we'll walk through an example and sort of revisit these topics again. The number one thing people do is there's an error, start typing, start sort of just going into it without first reproducing the error. Reproducing error is absolutely the most important thing. So when you see an error, you run the code, you see an error, the first thing you should do is trap the error, right? Find the condition when it works and when it doesn't. And that might seem like a natural approach, but I see so many people not do this. If they, for example, get a negative number when they don't expect it, just go immediately fix it, right? But what type of inputs are causing the negative number? Under what circumstances does it get the negative number? What circumstances does it not? Discovering the boundaries of the error. So sort of understanding the error is more important than jumping to the solution, because once you understand the error well, the solution is actually pretty easy. Usually there's 3 or 4 different ways to fix it, right? This is another reason why hack and slash doesn't, is not a good way to fix errors, because typically you're introducing more subtle errors, right? You're squashing the symptom, but there's other errors on the table there. Reproducing the error consistently, especially as you get to more complicated applications or programs, this is going to be the vast majority of the work. Because when you work with lots of external systems and the error only happens under certain loads or with certain data sets that you're not getting consistently, it seems sporadic. So you're always trying to say, okay, it seems like on Tuesday nights we're getting this error. That's weird, right? It turns out Tuesday nights is when you get a big data feed, weekly data feed from some external system, and it's overloading your system. So reproducing the error consistently allows you to quickly figure out the solution. I don't know if you guys ever watch, I'm deviating a little bit, but you guys ever watch Star Trek? I like Star Trek back in the day, and it's always amazing because Picard is able to make a quick decision only because his engineers give him full information about the error, right? So they'll always encounter some really crazy error with the space-time continuum, but somehow his engineers always say, if we do this, these are the consequences, right? But if we do that, these are the consequences, and it'll cost this much time or effort. He just has to make the decision. That's actually really easy, right? The hard part is coming up with a holistic solution, 2 or 3 or 4, with the consequences all laid out. Then you just make a decision because it's just trade-offs. The work of the engineer or of the programmer is really reproducing the error consistently. And I should probably add some words here, like understanding the problem holistically, right? That's really important. So many people just jump in, squash the symptom. Requires a temperament, right? Patient temperament. Figure out the solution. Okay, this is just a bullet here. So there's a lot of ways of figuring out the solution, obviously. I think, again, usually the case is if you understand the problem well, figuring out a solution is not hard. In fact, if you ever work on a team as a junior developer If you can go to a senior developer and say, I have this error, I don't know the solution, but I've analyzed the error, and here's what I found. Under this circumstance, it does this, and here's all the holistic picture. And under that circumstance, it does this. But I don't have a solution in front of me. That's actually a great sort of role for a junior programmer. But again, typically, especially in application development, what we do, the solution, it's not can you find a solution, it's, there's 5 solutions in front of you, and which one should you take if you understand the problem well? Arguably the most important thing here. And this is the last bullet here on line 11 is sometimes it's hard to see the error. So when you investigating the error and you're not sure what exactly is the problem, this is where sort of code smells can help. Code smells, unfortunately, will only be obvious to you, or they'll come you'll see it if you have some experience. So odd or unidiomatic code will jump out to you. Sometimes they're there for a reason, and sometimes it's because of an error. Usually I see a lot of beginners making the mistake of writing methods that do multiple things. And when you have a small program, you can contain that. For example, a method that returns a value, and you're using that return value, and it has a side effect, right? So if you have one method, that might be okay. As your program grows, that gets really difficult to work with. And a lot of subtle bugs kind of creep in. Sometimes you can look at the shape of the code, right? As you code a lot, it's kind of like writing. You'll have a general shape to it. And so when that shape is broken, or when an odd shape sort of reveals itself, you can sort of train your eye there. And obviously the last one is isolating complexity, right? Isolating when you have, again, a method that does multiple things, try to extract it to 2 separate methods. That helps you sort of think about the code. Those techniques, I think, are a little bit harder, especially, and more impactful if you have a larger code base to work with. All right, so before I get to tools, I'm going to work through this exercise, which you've already seen if you saw the previous recordings. And I'm just going to use this as an example. All right, so I'll quickly talk about this exercise if you haven't seen it. The premise is that we have an array here called products. This is sort of like our database. This is our products it's an array of hashes. And then we have 2 hashes here, a query and a query 2. And these hashes serve as filtering criteria. So I want to pass in these hashes into my method here that I have yet to implement, and they will return a subset of the products array based upon the criteria specified in the hash. So again, these are filtering criteria, right? So we've already seen somebody work through this exercise. I'm just going to pretend to walk through it using some of the techniques that I'm going to mention here in our bulleted list here. So specific techniques I want to talk about first is sort of spraying puts. I don't know if you guys ever heard of this, spraying puts. People usually say it in a pejorative way. I think it's a perfectly valid technique for beginners to use. No shame in it, I don't think, as long as you use it correctly. Right, so this should be P over here. Now, there's some very subtle things you have to be aware, though, as you're using it. And this is the expected technique, I would say, for most people in the first course here at Launch School. I would expect you to use this in Pry, I guess. But so if I were to write some code and there's some error here. So if I say products.select, right? So I can sort of see that, okay, this is a selection sort of mechanism. I'm going to now use let's say I want to search for all Dells. I'm going to hard code the Dell. So I'll say name is Dell. And I want to search for all the Dells. So the question is, how do I do that? How do I grab all the Dells? So product. So first of all, I want to see what product is, right? This is where I can use P to sort of debug. All right, if I execute this, I'm going to comment out line 41. If I execute this, do you guys know why I use P instead of puts? P instead of puts. So this is the difference. P is going to call inspect on this. So these are methods, right? So P is going to call inspect on the argument. and puts is going to call 2s. P inspect is going to give me a better visual output on collections like arrays and hashes than puts. So if I run this, right, you can see that that's the output. Now, okay, now I want to, so this is, I'm dealing with a hash here, and the keys are symbols. So I can do something like this, product name. And again, the next question is, how do I then determine, how do I do sort of a matching code here between this string, right, all these strings, ThinkPad, Dell, MacBook, with name? How do I do that? There's a lot of different ways, and I would probably play around with IRB. There's one called include, right? So the question is, does this, which represent these strings, include lowercase del? Does it include it? And if it does include it, then select it, and it should be returned here, right? So if I run this code, nothing's output. Nothing's output. So that brings to the second point of debugging, paying attention to the method's return value or versus the output, right? This is very important in that I changed something very subtle in the code here. I changed the method from outputting something to returning something, right? And as I'm coding or debugging, I have to be 100,000% sort of aware of this. Okay, so now I care about the return value. The return value of select is going to be a subset of the products array. A subset of the products array. So therefore, I'm going to return this to the P method, which will give me a pretty output, right? Empty string. So we weren't expecting that, right? We were expecting all the dells, right? I got an empty array. And by the way, if I use puts here, what do you think is going to happen if I use puts here instead of P? I can run this. Looks like nothing happened, right? It looks like nothing happened. So it's important to call the right method. P will actually show an empty array, whereas puts won't. So make sure that when you're debugging, use the right method. That sometimes makes all the difference. I always use P usually when I'm working with sort of data structures or custom classes. Okay, so the next thing I want to do is figure out how to debug this, right? I have a problem now. The problem is that I was expecting an array of all the dells, but I got an empty array. Okay, so you can certainly sit here and stare at it and try to think it through. That's okay too. Usually I want to try to be more systematic, and I'll show how to use pry. I already have this gem. Pry does not come with Ruby. Pry is a gem that you have to install separately. I already have it installed. So therefore, after I install it, I can say require pry. And then if I put binding pry in my code, execution will stop. And I can sort of take a look at the variables there. So if I put it here, for example, and I run the code, you'll see that it runs the code and it stops execution right where I put binding pry. This allows me to sort of take a look at the world in this program and try to figure things out. I can even change values. So I can look at here, what's name, it's del, what's query, it's this hash, right? What's products, it's this array of hashes. Very nice, right? I can kind of mess around with things and try to figure out what's wrong in a pretty systematic way. I can also do what's product, right? It'll say, can't find product, right? Name error. And I'll even try to make a suggestion, right? That comes with Ruby, and obviously we do not mean proc, right? So the question, so I put binding pry in the wrong place. To get out of here, I'll just do Control D. What I need to do is put it inside the select. Right, and I could put it, in this case, I can put it before or after. So I will put it right here. And then I'll run it again. And you'll see that the binding pry stopped execution once again inside the select block this time. Now, if I look at product, it'll tell me what product is. Last time when I was outside of the execution, it didn't know what product was, right? And I can literally copy and paste this code here. I'll say false, right? And so this is a systematic way of debugging as opposed to trying to guess. It'll say false. So now the question is, why is that false? So I can take it apart some more, right? Because there's actually this include this. So I can say, what is product name? Maybe that's the error. What if this is nil, right? Or what if this is not what I expect? Right, that's ThinkPad. Right, okay, so this is, in this particular case, I expect this to be false. Right, so I'll just continue forward. If I hit Control D, it'll go through the next iteration of the loop and stop again. And I'll look at it. Okay, that doesn't matter. Right, it's still ThinkPad, still ThinkPad, still ThinkPad, so that's all should be false. Okay, finally we get Mac. Okay, here's a del. Okay, so in this case, I'm expecting this to be true, right? Because my name, local variable here is del. So this is still false, right? That's the error. So if I look at product name, okay, it's giving me the right thing. And what about name? That's del. So I can basically reconstruct that, right, and say that include and get false there. And so this allows me to sort of be so much more systematic in the way I debug, as opposed to sort of staring at this code, right? When you stare at this code, you're working with a lot of different data structures. You're working with an array, with a hash, with a hard-coded value. If you didn't hard-code a value, you're actually working with a query hash here as well, right? So instead of name, you decide to go to straight for a query queue. Well, that could be a problem too. I should have maybe introduced that to, because I see this code a lot too, query queue, right? The error here is that queue, there's two errors here, and maybe debugging that would be more interesting, right? So let's give that a shot. Right, so we get, if we run this code, undefined method queue. Okay, so let's do this. And nil into string. Okay, so this is I'm getting a lot of errors. So what if I did 2s? Okay, suppose I wrote that code, right? Suppose I wrote that code and I'm not getting what I expected. So we'll play this game again. Okay. So once again, I can say product name. I can sort of just take it apart piece by piece, right? And then I can say, okay, what's this, right? Is this the... Okay, that's not what I need, right? So what's this? Oh, that's nil, right? And why is that nil? Okay, so because this is a symbol, right? So you're able to zone in on exactly what's happening as opposed to trying to decipher this code. You're able to sort of zone in. Oh, that's ThinkPad. Okay, I got the wrong value here anyway. Then you can sort of do what we did earlier, right? If it's del dot include this is obviously going to be false, right? But if it was del, it's still false. And the reason is because this has to be downcased, right? So if I downcase this, it's going to be true, right? So the error is that there's a capitalization mismatch. And I can downcase this. Now, I know in the video as where we had somebody walk through this exercise, he was able to recognize his error almost immediately, and therefore didn't have to go through that process. If you didn't recognize that immediately, I don't think your reaction is, "Oh my goodness, this person is so much smarter and I can't do it." Not true at all, right? You just have to be more systematic, and I think that's the key to this whole thing. It's not whether or not you make a mistake. It's not whether or not you can quickly identify the error and fix it. It's how systematic are you in your approach? Are you patient enough to sort of walk through this process and just take things apart one by one and debug it? Right? So the right sort of solution is query, and we have to make this symbol, right? Two errors. One is not downcasing this, and the second is not referencing this by a symbol. And if you understand this well enough, you can even anticipate that, hey, maybe, is there a guarantee that this Q coming in is going to be lowercase? If not, maybe I should just be safe and downcase this here as well, right? So that's the process by which you should slowly take apart a problem when you encounter it in the wild. And this is why attention to detail is so important, because even little things like not using P or puts correctly can throw you off. And if it does throw you off, then that's where programming, I think, gets really difficult, because there's, you got a couple bugs in one line of code and you don't have the tools to debug it, right? That's where people start to get into hack and slash. And that's where I think programming becomes less and less fun. As you become less and less systematic, it's just, it's harder and harder to sort of keep control of the code. Any questions so far? Okay, so one of the techniques also, or tools that I've listed here, is called rubber duck debugging. And this works so well that there's a Wikipedia page for it. So this is not something that we made up. This is an actual technique, and I knew of this before I knew it was called rubber duck debugging, because the idea behind this philosophy is that you have a rubber duck and you have to explain to the duck what you're doing. And it's through the process of that line by line, detail by detail explanation that you reveal the problem to yourself, or that you come across a path that you didn't go down before that you thought for sure would work. But as you sort of are systematically explaining it to someone else, you realize that you didn't go down that path. And then you go down that path and realize, yep, that is where the source of the error is. Obviously, it doesn't have to be a rubber duck. It can be another human being. It could be anything. But it works amazingly well. And I think part of the reason it works amazingly well is because it forces you to pay attention to details and have that logical temperament, right? And one I didn't mention was walking away for a bit. Now this one there's a caveat to this one. You can't do this one first. If you encounter a bug, you can't just walk away. This has to be the last thing you do. After you've loaded the problem into your head and you're stuck or you're burnt out, after a couple hours, it's pretty tiring. Right, and everybody's different. Some people can code for 4+ hours and just churn out a problem. For me, I don't think I can do it for more than a couple hours now. But that's okay. Yeah, know yourself. Walk away. Load the problem into your head first. Right? Use pry. Use the rubber ducking method. Spend at least an hour or so, right, thinking hard about the problem, not on Twitter or Facebook, but thinking hard, not just Googling either, right, not Googling and Stack Overflowing, but thinking about the problem, trying different ways of solving it, then walking away, because your brain will continuously work on the problem. in the shower, while jogging. You've heard so many of these stories, right, from other developers where, hey, I had this idea as I was doing something. Some people say it's because you're exercising a different part of your brain, and that's why. I don't really know why, but I know that that does work too. But again, only with the caveat in place. I've even solved problems when I was sleeping, believe it or not. And that's a really weird experience. You wake up and you go, wow, I was sleeping and I thought of this in my dream. And you come to the office the next day and you try it, and sure enough, that's a solution. So your brain's always working on the problem after you've loaded it into your head. So you don't necessarily want to burn out just by staring at it for hours and hours. Yeah, this is, someone else mentioned a debugger. So the last thing I want to talk about is using a debugger. We don't talk about it in this course because it can get pretty complicated. Stepping through code is what a debugger allows you to do, and also stepping into a method or a class. That's really nice if you're working on a larger code base. You won't need that in 101, but I would say a lot of professional developers will use a debugger, but also a lot of application developers don't. So I should just mention it, right? So Pry allows you to use a debugger. I don't think Pry itself does. You have to have additional gem or add-on to Pry that turns Pry into an official debugger. Very, very nice. You can step by step, line by line, walk through the code. Just hit next, next, next. And then you can, instead of this sort of finding Pry where it's fixed, right, you can actually go on to the next one. And then you can like jump into this method. But we're not going to use a debugger in our program or in our course because it doesn't, none of our programs get that complex, right? So I want you to first sort of understand the difference between puts, print, and P, and how it changes the output. The second is paying attention to the return value, because if you don't, you're going to be very confused. And as I demonstrated earlier, when we use puts here, it seems like nothing happened, right? And you might be staring at your code some more and tweaking something else, whereas something did happen. It returned an empty array, right? So understanding that is really important. And also the last thing I'll talk about here is, let's say I'm doing some debugging and I do a puts name. How did I just change my method here? So you see that? And if I further did puts here, it would be even worse, because it'll say del and then seemingly nothing happens. That completely changed my program. And the reason is because puts here is going to be the implicit, it's the last expression in my search method, right? This puts method invocation is the last expression in my search method. Puts will output the name variable and it returns nil. Okay? That means that this code is the same thing as puts nil, right? So line 39 returns nil, which will be this. Now I'm putsing nil. Remember, puts calls 2s. Puts calls 2s. Remember that. Nil.2s is empty string. This is why we see this here. So I'm putsing the return value of puts, which is nil. I'm putsing a nil, right? That ruins your entire program. So very important to not do that, even if you're debugging. So sometimes your debugging code can cause sort of inadvertent issues, right? And another thing to sort of pay attention to, I think a lot of people are confused here, is if I do this, so I move that puts name to here, is this okay? What's going to happen here? Right, empty string. But that wasn't nil, right? See the difference? So how come, I just moved it from this puts on line, well, let's say on line 39 to line 37, right? Just for debugging. But it changed. It went from nil to empty string, right? And the reason is because this is now the last expression in the select block. Now select is using it as the selection criteria, which means it's nil, which means it's false, which means no products were selected, which means it returned an empty array. The key thing to recognize here is that select is the last expression in this method. This block here is an argument into the select method. Right? This code is sometimes hard to read, and you can have a lot of code inside a block. Right? You can have a lot of code like this, and you're saying, what is the implicit return value of this search method? Let me look here. Oh, it's this. So it's nil. Nope, it's not. It's select. In this case, the last expression, this is the last expression in the select block, returns nil, false, which means nothing selected, which means empty array is being returned. Right? Very subtle bugs you can introduce as you're debugging if you're not careful. Very, very subtle, hard to debug. So you're causing, if your debugging code is causing sort of problems, then it makes it more difficult. This is why some people don't like spraying puts all over the place, especially in Ruby. So using pry sometimes can be a little bit more helpful, but if you do use puts, just be very, very careful about, especially its return value, and putting it as the last line of a method or of a block. Dramatic differences. Okay, I think that's all I have for debugging. I have a couple of coding tips I can talk about. But before I do that, any questions? Oh, I do have some questions here. Let me see. I think the most important is code with intention. Right. When there is no complete understanding, it becomes really hard to code efficiently and not get frustrated with it has to work, it's not working for me. Right. I think that's right. So, and I think these two things come hand in hand, coding with intention and the attention to details. Because you cannot code with intention even if you say, okay, today I'm going to code with intention. Okay? I'm not going to hack and slash. Well, if you did not study the details of how things work, you're not going to be able to do this. Right? And this is why you have to constantly, this is why if you ever pair with like a senior developer, you'll see how often they have to hop in IRB. You'll see how often they have to consult Ruby documentation. And you go, don't you know that? Or have you been doing this for many years? And the answer is, yeah, of course. I've been doing this for many years, but I don't remember every single detail of every single method, that even if I've used it, a ton of times over a period of many, many years, I still have to consult documentation just to make sure, right? Double check about how what the details are, because that's really important, right? I can sort of code, with fuzziness, right? But professional developers usually are very fanatical about that stuff. Is that a reason that spraying puts is frowned upon? Yeah, I would say that's a huge problem if you don't know, if you aren't consciously aware that your debugging code is causing problems. Binding pry is the same way, right? You don't want to leave a binding pry as the last expression most of the time. So you have to be careful when you're putting debugging code in the middle of your code, especially with implicit returns, right? We have two implicit returns here. One is the implicit return. Well, this is not an implicit return. The last expression in the block is going to be used as the selection criteria. The last expression in the block. So I can write all kinds of code up here all I want. If my last expression is nil or false, then it's not going to be selected. This current element is not going to be selected. And the other implicit return for the method is that it's select right now. If I add anything here, then none of this matters. select's going to return nil. The search method is going to return nil. Okay, so a few minor coding tips that I'll mention is, one is regarding methods, or most of them are regarding methods. I've mentioned this, I think, many times, and I think it's important to reiterate, and even experienced developers, I think, sometimes make these mistakes, which is when you write a method, usually it's to extract something. Now, as you get better at programming, I think you can anticipate more. But in the beginning stages, I think it's very difficult to anticipate. And so you have to extract redundant code to methods, not go straight for methods. The second thing is when you do extract for methods, have a consistent naming scheme. So, for example, if your methods are, if we have like a, I don't know, like our sort of search. So if our method is search, that's a verb. So your methods should be verbs. And implicit here is products. So this program deals with products. So they should be at like a similar level of abstraction, right? And you might have different groupings of methods that operate on a similar level of abstraction, right? So you want to, so if we're working with an array here, right, we can do some sort of transformation, right? Or maybe not transform is too generic. Maybe it's like append, right? Or insert, right? Insert in like the middle. Let's say that's like sorted or something like that, right? So these should be verbs. If you see something like, I don't know, if it's iterate over names, I mean, that might even be okay, but it's sort of, if you have all of them sort of at this level and this one all of a sudden is different, it feels a little odd. So have a consistent naming scheme. Another one I like is if you have some methods that are outputting, prepend it with something like display or print, right? Like print names. And that will give you a hint as to when you need to use it that it will actually display some output. Now, what's important is that you don't use print names like this. You don't say names equals print names. Without even implementing this print names method, you can see how confusing this code is. Okay, are you printing names or is it returning names? Like what is this method? I have to go look, right? So you want to just say, names equals, retrieve names or something like that. Right, and then you say print names. And so this method, you can tell we don't care about the return method, right? We're not keeping track of it. This method, we are keeping track of it. And along the same line, when you're mutating something, usually you put an exclamation mark or at least give some sort of hint. Something like that. Maybe like that. This can get quite annoying if all your methods are destructive and they're all bangs, right? That's maybe unnecessary. But update names kind of gives you an idea. Yeah, it's updating names. This will be confusing. Right? This might be a little confusing. Maybe change, right? Something like that will maybe be a little bit better. And make sure if this is the case where you want users of this method to only worry about the return value of this method, then make sure that this method doesn't have any side effects, including output. So you want to try to keep methods sort of at the same level. If you say, well, what if in this method I want to output something? I mean, that may seem like something you want to do. So if this is a method where the logic is do something, output something, do something, then you should extract that first do something block to a new method, output it, then we say do something 1, print message, then do something too. In other words, put the orchestration code in one place. If this method contains some orchestration code and your main code here contains some orchestration code, it's confusing. Just have the methods do one thing and you'll be able, and try to keep the orchestration in one place. You'll have a much better time debugging it. Right? This all goes back to debugging because these tips sort of are a little bit hollow in isolation. It's like, you should do these. Okay, I guess if I do or don't, that's okay. But when you're debugging things, you'll wish that you did this, right? You'll wish that you could isolate things into very logical chunks that either return or have side effects, and they're contained, and you don't have to worry about jumping into every single method to see, oh my goodness, this method is doing 3 different things. I have to walk through not only the code that I'm writing, but I have to walk through line by line the methods in this method, the code in this method. If this do something 1, we just care about the return value, whatever this, then I can actually just execute this method with perhaps different arguments to sort of get an idea of what this method is without having to go into the method and look at its implementation and try to analyze where the error is. I can just feed it input and observe its output. Anyway, that's all I want to talk about. This is a huge topic, and in the course there's actually a lot of, I think, topics related to debugging and coding tips, and all the coding tips really, I think, facilitate this general idea of helping you debug. So, any questions? There's a couple of questions here and there, but I didn't see anything major. That's all I prepared for today. I think if this is a hard topic to talk about once and go, yeah, okay, I got it, right? This is more or less a day-to-day thing. Maybe the biggest takeaway I think that's actionable immediately is using pry and paying attention when you're using puts versus p for the most part, the return value of those things, very important. And when you're looking at code in terminal versus IRB, it shows up very differently, so you got to be careful. I know I didn't demonstrate IRB too much, but if you say in IRB, it will always show you the return value, which is nice. Sometimes you can't jump in IRB because there's too much code. And when you execute it from the terminal, it may or may not be shown the return value of the method or the return value of the code. It may or may not be shown depending on how you're printing it out. So that's something to be careful about. Okay, well, that's all I have. And thanks for showing up on a Saturday. Hope this was helpful to some degree. If you have any other suggestions, like I said, please follow up with me over email. All right, everyone. Thank you.